This video has just got a few ideas of how you might be able to do addition and subtraction a little bit easier. So you might be happy just doing all of these using your standard algorithm. That's perfectly fine. Okay, but you might want to consider, hey, if I'm doing 25 plus 35, might it be easier for me in my mind to break it into 25 plus 5 plus 30, or alternatively 25 plus 30 plus 5, and just doing those steps individually, going to 30, then to 60, or going to 55, then to 60. So getting the same answer both ways, but maybe not needing to rely on this whole algorithm. So in a similar way, 56 plus 95, okay, you might be happy just doing the algorithm with that. That's perfectly fine. Might get stressed out in the exam, but that's up to you. 151. Okay, or you might think, hey, instead of adding 95, why don't I think of that as adding 100, but I've added too much, so I better take away 5. So 56 plus 100 would be 156. Remembering, need to take away 5 and get to 151. Okay, so you might be able to just do that completely in your head. Might save you some time, get you a bit more confident. If we have a list of numbers to add, remember, if it's all addition, we can change the order completely. Okay, so instead of going 5 plus 2 is 7, plus 7 is 14, oh, I'm under pressure, I don't know what to do. I'll just look for some groups that are convenient. So I know that 7 and 3 makes 10, and then I know that 2 and 3 makes 5, and this other 5 will make another 10. So I'll be able to just notice that that's 20 without having to go through each individual number. So looking for groups that make 10, looking for groups that make 100 might save you a lot of time. And the other strategy for addition is just getting to some benchmark goal like 10 or 100. So 98 plus 17, I'll think, all right, I'm on this number line, I'm at 98, I need to add 17, but I'd rather just add 2 for the moment to get me to 100, and then remember that, hey, I'm adding 17, so then I better add another 15 to get me to 115. Okay, so breaking down this into plus 2 plus 15, just to make it into 2 smaller steps that might be easier for me than trying to do the whole thing in my head or getting sidetracked doing these algorithms. Okay, so that's enough addition strategies. Some subtraction strategies as well. So 100 minus 18, I might not be particularly comfortable subtracting 18. So instead, I'll take away something bigger. I'll take away 20. But I've taken away too much. I've taken away 2 too much, so I better give 2 back. Okay, so I'll end up with 100 minus 20 is 80, plus 2 gives me the 82. So anything where you're subtracting something like 19, subtracting 99, you might want to use that strategy. Okay, in a similar way, be able to use a number line strategy. If I start at 103 and I want to subtract 24, I might think, hey, it might be easier for me just to subtract 3. And then remember that, hey, I need to also subtract another 21. So you might be really good at subtracting from 100. That might be something that just comes like instantly to you. Okay, so getting to 79 might be easier this way, especially given some of us forget how to do the trading and borrowing when we can't do the subtraction algorithm directly. Okay, get the same answer. The final one's probably my favorite one to show students. I love seeing students struggle with this one and trying to remember, hey, how do I borrow from the thousands to give to the ones? Okay, but really don't need to be doing that. If I just have a number line, see this subtraction as, hey, what's the difference between 2003 and 1998? Here's 1998, here's 2003. So what's the difference between them? Takes me 2 to get from 1998 to 2000. and then another 3 to get from 2000 to 2003. Okay, so it's useful for those sort of exponential growth and decay problems where you might need to find how many years have passed between two particular years. Don't need to be messing around with this algorithm, just visualize it on a number line.